Hello again. I wanted to explain why these binomial distributions are called binomial distributions and also show you some lovely pictures. So remember, for a binomial experiment, each trial results in a success or a failure. Each trial is binary, success or failure. Just as a bicycle has two wheels, a binomial experiment has a binary result for each trial. Each trial results in either a success or a failure. The coin comes up heads, success, or tails, failure. A student gets a question correct, success, or wrong, failure. The die comes up a 4, success, or doesn't, failure. Also, another reason why it's called a binomial distribution, because as I mentioned earlier, it's involved with expanding the powers of binomial expressions. A plus b is a binomial, a two-term polynomial. The cube of a plus b, it can be worked out in this fashion, and these coefficients are called binomial coefficients, the 1, 3, 3, 1. They're called binomial coefficients. Also, these pictures, a gallery of binomial histograms. I have 50 of them here for various values of n, the number of trials, like for example, the number of questions on a test or the number of coin flips, and p, the success probability per trial. For a fair coin, you're looking at the center column. For p equals 1/4, that could be a multiple choice test, A, B, C, D for each. But anyway, look over here, for example. You flip a fair coin 3 times. N equals 3 trials, P equals 1/2. The probability of no successes, no heads, is 1/8. The probability of 1 head is 3/8. The probability of 2 heads is 3/8. The probability of all 3 flips being heads is 1/8. Notice this is symmetric. A related problem, if a student takes a multiple choice test with just 3 questions, maybe it's a short quiz, 3 questions, each of them true, false. The student guesses randomly on all 3 questions. Then again, here's the probability distribution for X, where X is the number of questions correct on the student's part. Now let's examine these binomial histograms and notice, especially in that center column, as n gets larger and larger, n equals 10, p equals 1/2. This is the simplest binomial histogram that we're going to approximate with a normal bell curve. Something to look forward to.